Good morning, good afternoon, and good evening, wherever you are in the world. My name is Jean-Michel Vuillamy, Technical Sales Specialist at Intel PSG. First, I would like to introduce you to Jean-Baptiste Laurent, Sales and Marketing Director at intoPIX. Hello, Jean-Baptiste.
Hello, Jean-Michel. Thank you for this invitation.
Today, Jean-Baptiste and I would like to give you an overview of the JPEG XS FPGA evaluation kit, which is launched as part of the Intel Edge-centric campaign. Here is the agenda. Jean-Baptiste will first give an overview on intoPIX, then an overview of the JPEG XS codec, explain the advantages of JPEG XS, namely high quality, low latency, and low complexity. Then he'll go through the target applications for JPEG XS on Intel FPGA. Finally, I'll conclude by explaining how to start with JPEG XS on Intel FPGA. Jean-Baptiste, the floor is yours.
Thank you, Jean-Michel. So, who is intoPIX? So, intoPIX, we are located in Belgium, but with a presence all over the world. We are a company of 30 people, specialized in image compression and video compression technologies. We are creating technologies that we are delivering as FPGA IP cores and a software development kit. We have a track record in research, innovation, and standardization process, being an active member, for example, of the ISO JPEG committee, but also audiovisual industry consortium like SEMTI or AIMS, VESA. We are very active since 2006 in a professional AV, media, broadcast, entertainment, digital cinema, vision, industrial vision, medical, aerospace, automotive, and consumer electronics. And of course, we are a proud Intel partner in FPGA and software development. So people know us also thanks to our strong presence in digital cinema. In fact, all over the world, in 65% of the cinema, the theaters, you have an intoPIX technology embedded to decode the most beautiful content. The company received some Emmy Awards and other awards for its active participation in standardization interoperability for live broadcast transmission technology. We are a pioneer in a new TV format, for example, in 8K. Since more than 10 years, intoPIX is taking a strong investment and participation in 8K super high vision TV development. And we also recently introduced raw image sensor compression to make raw Bayer data faster, better, and smaller to enable smart camera design and raw workflows. But I'm not here to speak just about intoPIX. I'm really here to speak about the JPEG XS technology. So JPEG XS is a completely new video codec standard. The technology has been co-created by our company along with industrial international expert in image and video compression. You know, JPEG is a wide standardization organization, so everybody knows about JPEG, but there is not just one video or image codec in the JPEG committee. You have multiple, and JPEG XS is the latest one, where XS stands for extra small and extra speed. So with JPEG XS, the target is to enable to manage more pixels, to save cost and power, to preserve quality without any impact in latency, and to simplify connectivity. So what makes JPEG XS different? So it was really a completely new approach to create a video codec. So traditional approach like MPEG-2, H.264, HEVC, AV1, VP9 have always been looking at compressing as much as possible. And that's what you can see in this graph when you look at inter-frame codec, so distribution codec. In JPEG XS, we take another route. We look at what could we achieve in terms of compression efficiency, but with the following constraint. We want to preserve a low latency. We want the compression to be very low in complexity. We want it to be very efficient in hardware platform like an FPGA or an ASIC, but also efficient when you will have to run it on a CPU or GPU, for example, and preserving the quality. So we really aim with JPEG XS to replace the uncompressed video wherever it is being used. So what does it mean in terms of performance? So preserving latency, low complexity, here are the typical bitrate that can be achieved with JPEG XS. Whether you have an HD or 4K or even an 8K application, this is the kind of supporting bitrate range that the intoPIX JPEG XS implementation in FPGA or even in a software system can achieve. So I put some example of a range from HD to 8K. What is nice is if you consider a network, for example, is that you can support one or multiple stream over Cat5e cables, go below 1 gig, below 5 gig, below 10 gig, depending on the type of video format. It already brings a lot of advantage knowing the constraint we have in many local network or for even a remote location of a wide area network. But the question is about the quality. So we said JPEG XS will replace uncompressed. So we have been using in JPEG XS standard a new methodology to assess the quality. So we have really a perfect pixel quality with JPEG XS. When we assess the quality, we went down to a 10:1 compression. So it's like a 3 bit per pixel if you have a 444 10-bit content, and we saw that we were fully transparent on a various set of content. So not just a natural movie content, but also using a graphical content, desktop content, CGI. And the method that was used is actually an ISO standard, where you will compare left side and right side of the image, and one side of the content you will interleave it with compressed and uncompressed. So this is a flicker test, and the eye will be very sensitive if there is a difference between the compressed content and the uncompressed content. And when we were looking at the compressed content, we were not just compressing one time the content, we were compressing it up to 7 times. So you take the content, you compress, decompress, compress, decompress, and you do a 7 loop of encoding, decoding. So this way, you also know that if you use this technology as a replacement of an uncompressed interface, that you can go over multiple interfaces in cascade and you do not lose quality. Moreover, the JPEG XS use a wavelet transform system, and the advantage of wavelet versus traditional DCT codec that use a block spatial division is that with wavelet filter, when you compress too much, you have only a loss of smooth detail. So if you are in a lossy world, if you start to lose because you compress too much the content, even in such case, the quality remain friendly for your eyes, which is also nice if you want to use the compression beyond 10:1, like even at 15:1 or 20:1 in some cases. So on top of that, intoPIX has developed also additional methods that come as additional add-on if you have an application such as a KVM desktop, remote desktop. We call that the intoPIX flawless imaging processing, and this can be used on top of our JPEG XS codec to compress more the most complex content, so beyond the 10:1 compression that was assessed for JPEG XS standardization. So we can speak about the quality, but we have also to speak about the latency. What do we mean by I can replace and compress and I don't have any impact of latency when I'm compressing? In fact, JPEG XS works on a line by line. So we do not bufferize too much video content to compress the video stream. We just need to keep a few lines of pixel along with the compression. So basically, we speak about an encoding and a decoding that goes below 1 millisecond. So it's in microseconds. So we know that humans are not able to detect typically a latency below 13 milliseconds. That's what the MIT has been proving. We know how sensitive latency is important in many applications, like to make a decision on time in an industrial vision application in a factory, but also to have interactivity application like a remote desktop or in a Pro AV where you have a video wall that you need to control. You don't want to suffer latency, or in a gaming application, for example, over a network, latency is really annoying. So JPEG XS is really well designed for a latency critical application. And moreover, it brings a constant bitrate compression. So everything is predictable. So it's not like if the latency could vary over time, or vary with the compression ratio, or if the rate could change. No, everything is predictable. So you have like 10 lines of latency to encode, 10 lines of latency to decode, and this won't change. So that's a huge benefit for implementers as well. And then minimal complexity. So what do we mean with minimal complexity? So intoPIX has a very strong experience in implementing video codecs on FPGA. We've been looking at a technology like a JPEG 2000, but also H.264, and how large they could be on an FPGA. The cost, also the power consumption of a video compression engine. And here with JPEG XS, everything has been taken into account to be very cost effective, power efficient in the algorithm. So the fact that we only bufferize few lines for the compression means that you don't need any external DDR when you implement such codec. The fact that we look at an entropy coding that can be very efficient on FPGA means that it's like a 4 to 10 times smaller than a traditional JPEG 2000 compression that were used before. We have a different also profile. So depending on the compression ratio, we can apply different profile, and the complexity will scale with the level of compression that you need. So if you need 2-to-1 compression, you can implement a profile that will be suitable for 2-to-1 compression. You need 10-to-1, you implement one that will be slightly more complex, but still very low with very low complexity compared to other codecs. But it's not the only thing what we mean with minimal complexity. So beyond the FPGA implementation, we've been looking at how much degree of parallelism we offer in the algorithms to be friendly with an Intel CPU or GPU, and so that we can really parallelize efficiently the encoding and the decoding over a processor. And the result is very impressive, of course, which enable to have a really hybrid solution where you have, for example, a camera that is low power running on FPGA, but a desktop station that can decode perhaps in software some stream. That's really something pretty new. And if you look at other traditional compression in the world, they all need an hardware accelerator, whatever the application. An H.264 in software is just a nightmare. JPEG 2000 is very complex in software, for example. And JPEG XS then solve that good equilibrium to be efficient in FPGA, efficient also in a CPU or GPU. And beyond the complexity, the latency, the quality, of course, our world is moving so fast today that you need a standard that is also future-proof. So when the standard has been designed, but from day one, we took an approach of being friendly to any kind of resolution, support any kind of chroma format, such as 444, 422, 420 monochrome, also any kind of color space, RGB, YUV, but even raw Bayer compression is coming, so image sensor compression will be standardized at JPEG XS as well. Multiple bit depths, so today you see 8, 10, 12, 14, 16, but even in the future 20 bits or 24 bits is already being considered as extension of the standard. HDR is of course supported. You can signal any kind of HDR. You have all the right metadata to transport HDR information, and it has no limit in frame rate. And a nice thing also is that it's also friendly in scalability. So we are in an ecosystem where we have multiple resolution to be supported in the same workflow. Some display that might be limited in resolution and supporting only HD, 4K or 8K. And in such case also, we are able to offer scalability. So I'm just trying to move to my next slide. Yes, I got it. So here you have exactly the example. So if I receive a very high resolution stream, my decoder can extract different layers of resolution from a single JPEG XS video stream. So for example, I receive a 8K stream, and from a 8K stream, I can decode a 4K and a HD stream. And here the example is about 4K. I got a 4K stream, I can decode a HD or a quarter of HD resolution. It is pretty nice for monitoring, multi-viewers, proxy video walls, but also think about in an industrial application where you have AI classification, a huge data set that has been encoded in JPEG XS. You don't need to completely decode each images. You can just parse, decode partially, and already start your AI classification process. So this is nice. But then let's go to also the implementation side of it. So the good news is also that it's ready and you can start to implement it in your own design. So we have a very large range of encoders and decoders fully compliant with JPEG XS that we developed over the last year. We have IP cores for HD, for 4K, for 8K. Some IP support just 30, 60 frames per second, but we have also solution for high speed, can go up to 1000 frames per second if you want. We have a broadcast oriented IP like doing only 422, but we have also IP for 444, 422, so for KVM display application. We support different bit depths. The compression ratio is adjustable. We have, as I said, 10 lines of latency to encode, decode, no external DDR. And we can fit almost any Intel FPGA from the smallest device like the Cyclone up to the latest family like the Agilex. We can often put multiple encoders and decoders in a single Intel FPGA also, which is a good benefit for a wide a high number of channel support in some application. And we provide a companion IP core. So we have the TICO XS Square IP that embed the intoPIX flawless imaging processing more for KVM desktop Pro AV type of application. We have the RTP packetizer for XS. If you build an over IP system, we can provide the payload encapsulation for JPEG XS. We have MPEG-2 transport stream IP core for it, and even IP cores if you want to map JPEG XS over an existing HD SDI or 3G SDI cable. We provide this IP. So do not hesitate to reach intoPIX if you want to get more information on this solution. So in terms of application, so as I said, JPEG XS really replaces uncompressed video. So in any application where latency is important, complexity is a problem, you can use JPEG XS to replace it. So you have applications such as live production, in a studio, but also remotely. Remote video assist referee, also in sport, live sport, it's very important. Processing to the cloud, so in live for storage, optimization, connectivity. Also in the automotive connectivity, but in chip-to-chip interface, so between just two chips, you have a limitation, a bottleneck. It can be solved with JPEG XS. In display and mobile, so to connect a very high resolution display with a low latency and a lower throughput interface. AR, VR, where interactivity is very important, so you can easily use JPEG XS to reduce the bandwidth, preserve low latency. So any 5G wireless application, and you can think about that now with Wi-Fi 6 we have a bit more bandwidth to transmit. 5G also offer that and lower latency, so there is a kind of good match with JPEG XS for this new technology. And as I mentioned, AV over IP, KVM application that are for example limited to 1 gigabit Ethernet Cat5e cables. You have a good match to transport a 4K 60 444 12-bit over this kind of applications. What do we mean in terms of sizing? So I put here some example on the Cyclone 10 GX FPGA for a 4K 60 444 12-bit, an encoder and a decoder. You see it's pretty small, but what you see here is a configuration for a compression that can compress a lot. So this is the highest profile of JPEG XS. We can always scale down the size if you have a different requirements. If you want like just 422, lower bit depth, different resolution, HD only, depending on sometimes on the Quartus tool also. So if you the size can change if you want to add the flawless imaging processing. So contact intoPIX if you want to get more details on that. Feel free to contact us, but also Intel, and we'll be glad to provide you the accurate numbers according to your application. And finally, the exciting things that Intel is releasing now, but I will give the words to Jean-Michel about it.
Okay, thank you, Jean-Baptiste. Okay, so now how to start with JPEG XS on Intel FPGA? Intel has a complete evaluation platform for JPEG XS, which is based on first the Intel Cyclone 10 GX FPGA dev kit, second the Intel HDMI 2.0 FMC daughter card, third HDMI Intel FPGA IP, and last but not least the intoPIX TICO XS bitstream supporting the evaluation. So the way the demo works is that you can feed the JPEG XS FPGA evaluation kit with a video stream through an HDMI 2.0 interface. The video goes through intoPIX encoder, then decoder, and the result can then be visualized on an HDMI 2.0 monitor. So that's the demo. Now, what can you achieve with this demo? First, you can actually confirm that there is no latency through the encoder and decoder. You can open a timer on the source display and compare it with a sync display by taking a picture of the two displays side by side with your mobile phone. You may also check the latency simply using the NIOS terminal. Second thing, you can confirm the quality is perfect with side-by-side comparison of the source on the sync displays. You can play with various compression ratios and formats. And also, you can dynamically bypass the encoder on the decoder. Finally, with this solution, you can confirm the low complexity of the JPEG XS implementation. All this is running on a Cyclone 10 GX FPGA, which can support up to 4K resolution, up to 60 frame per second frame rate, up to 12-bit in 422 or 444 formats. Okay, so with this, we conclude the presentation on the Intel JPEG XS FPGA evaluation kit. Please use the links at the end of the presentation to learn more about this solution. Also, feel free to contact Jean-Baptiste or myself in case you have any further questions. Thank you very much.
Thank you. Bye-bye.